another important kind of data that computer programs need to manipulate. And in computer programming, we call any segment of text a string. We've used strings before. For example, the format string of the built-in function fprintf is, as its name implies, a string. And we've just used the int max function, where the argument was the name of the data type that we were interested in, and that's a string. So what is a string in MATLAB really? Well, it's a vector of characters. In other words, it's a vector whose elementary type is char. We saw this when we used the class function earlier in this lesson, so it shouldn't come as a surprise. What will be surprising, though, is that char is a numerical data type. A char is actually a number, and behind the scenes there's an encoding-decoding scheme that specifies what number represents what character. The oldest such character encoding scheme is called ASCII, pronounced ASCII. ASCII stands for American Standard Code for Information Interchange, and it was developed in the 1960s. An ASCII character code is 7 bits long, so it can encode a set of 128 characters. As you can see in the table, the ASCII set includes the Latin alphabet, the digits 0 to 9, punctuation marks, and some special characters. For example, 36 is the $sign, while 97 is the lowercase a. Of the special characters, we care about the new line character, abbreviated NL, and having the code 10, and the space marked SP and encoded as 32. 128 characters seem like plenty in America in the 1960s, but nowadays, well, we need more. Just think of all the characters in all the world's languages, and most importantly, all the emojis that we just can't live without. So over the years, many other schemes with far more characters have been developed. The good news is that little old ASCII is a subset of pretty much all of them. Let's dig a little deeper into this subset. Here's a function that prints out all the visible characters in the ASCII table. It uses a for loop with a loop index that starts at 33 and ends at 126. 33 is the encoded value of the first visible character in the ASCII table, which happens to be the exclamation mark, and 126 is the value of the last visible character, which is the tilde. Inside the loop, one character is printed at a time using fprintf with the %s format string. You may remember that %s expresses a string, so the second argument of fprintf is the value of the loop index converted to a character by the char conversion function. After the loop, we print a new line as usual, and that's all there is to it. Okay, let's see how this thing works. I got it right over here in its M file. And there it is in the editor. I'll just run it. And it works as advertised. Here at the beginning is the exclamation point that we get from ASCII code 33. And over here at the end is the tilde, whose code is 126, with all the other printable characters arrayed here in between. As it turns out, we can make it even simpler. As I said, the %s in the format string of the fprintf function tells the function to expect a string argument. More exactly, what it tells the function is that whatever argument it gets should be converted into a char. So we don't need to use the conversion function char here. We can simply use II. And the %s will treat it as if it were a char. Let's try that. Same result. And if we want to look like a wizard, we can even change the last line like this. Which says to fprintf, print the number 10 as if it were a string. 10 happens to be the code for the new line character. So if we tell fprintf to expect a string and then give it the number 10, it will convert it to a char with the value 10, which is just the new line character. And we get the same result again. This time we're magically getting characters out of nothing but numbers up here. And what does character mean exactly? Well, these so-called characters that we're looking at here, the ones that are being printed to the screen, are actually just arrangements of tiny black, white, and gray pixels that look to our eyes like familiar symbols whose meanings we know. Let me turn on my magnifier here to show you what's really there. There. See those little gray pixels and white pixels and black pixels and so on? Look like a 1. They look like a 2, a 3, a 4, and so on. Well, here's a D, an E, etc. So we give MATLAB a number, tell it to treat it as a character, and it produces a pixel pattern that symbolizes something to us. Okay, we peeked behind the curtain and found that there's no wizardry in strings at all, just ordinary numbers, a conversion table, and some pixels. The rest of it's all in our heads. Let's play some more with strings. This was plan B if the title Computer Programming with MATLAB didn't work out. Now I'm going to treat this string just like a vector, just to prove there really is one. There, you can check its length. Like up here, you can index into it. Here's number 1 index. You can use the colon operator to give it multiple indices and use the end and so on, just like you can with any vector. Those are advantages. But there are disadvantages too. Because they're vectors, comparing two strings is not as easy as comparing two scalars. So let's see. You cannot just compare two arrays with the double equals operator if they don't happen to have exactly the same size. It violates the rules of array operations. And even when our two strings are the same length, the result of the comparison is probably not what we want. Let's illustrate that with the word MATLAB, which we'll pluck out of this title again. You ever ask yourself what MATLAB spelled backwards is? It's Baltum. As in, that stupid bug showed up out of the blue. It was just totally Baltum. Anyway, MATLAB and Baltum are the same length, so we can use them as operands for the double equals operator. So let's try it out. We get a vector of logicals, which is what you get for any element-wise comparison of vectors with a relational operator. Instead of the answer we want, like, these strings are not the same, we get one answer for each pair of chars in these two strings. And since, as it happens, only the A's match up, the second and the fifth elements are the only true values in the resulting vector. The rest of them are false. In a minute, I'll show you a helpful function for comparing strings that will give us the answer we want. But for now, I'm going to show you how to have some fun converting chars to doubles. Okay. We started with a string. We converted it to a double, and now code is just a vector of doubles. Let's tweak the values in code just a little bit and then change the code back to a char. So we're adding 3 to every element of code. Then we convert it from a double to a char, and we put the result in secret. Let's see what it looks like. Will you look at that? We've encrypted our message. We can send this to our friend now. Even if it's intercepted by the teacher, he won't have any idea what it says. But our friend is a MATLAB programmer too, so she can decode the message easily. Here's how she'll do it. All she has to do is know the secret tweak, which was to add 3, and she just undoes that by subtracting 3. Told you it was going to be fun. We found another advantage of the fact that a string is a vector. We can send secret messages. And on the subject of a string being a vector in MATLAB is just a one-dimensional array, so we've in fact got an array of chars here. So can we have a two-dimensional array of chars? Yes, of course. Bill is an array. Well, it's a one-dimensional array, so it's a vector, and it's the first row. Mary is the vector of the second row. John's the third row, and so there's our array. It's a two-dimensional array of char. Let's try another one. So that works great too. So far we've got a 3 by 4 array, and now we've got this 2 by 8 array. Let's do an array operation on this array. We'll do a transpose. We're on a roll here. Let's get a little more ambitious. Oh no! What just happened? What kind of an animal is a vertcat anyway? Well, vertcat is a built-in function, not a feline. MATLAB uses vertcat internally for vertically concatenating the 2 vectors we provided into a matrix, but it didn't work here. Can you guess why? I cannot hear your answer for some reason, but I'll give you the benefit of the doubt. Yes, that's right. We were trying to create a matrix in which the 2 rows, this one and this one, had different lengths. You'll see this error message quite often because there are lots of times when you'll accidentally try to give the rows of an array different lengths. To help you remember what vertcat means, it might be worth pointing out that vertcat is a contraction of vertically catenate, because catenate and concatenate mean the same thing, just like inflammable and flammable. In this case, MATLAB complained because the first line of the text had 28 characters, tiger, tiger, burning bright, while the second, in the forest of the night, had only 27. Oops. That's a big no-no in MATLAB. So you have to be very careful. In fact, typically you shouldn't try to store strings in matrices because they're rarely of the same length. We'll show you how to store strings the right way and how to compare strings the right way too. These tasks and others that deal with strings require a little finesse, but fortunately MATLAB provides specialized functions and additional data types that'll make it easier. MATLAB provides a set of very useful built-in functions to help us deal with strings. We'll recommend a few of the most useful ones, which can help us with 5 common tasks involving strings. First, searching for a substring inside a string is made easy with the function named findStr, which means find string. Second comes conversion of a number to or from a string. Now that we've learned about strings, we know that a double with the value 123 is not the same as a string of characters 1, 2, 3. They look the same, but they're fundamentally different. One's a floating point number, and the other's a vector of 3 chars. However, you can convert back and forth between them using num to str for number to string and str to num for string to number. Third, when we need to compare two strings, we've seen that the double equals operator doesn't really do what we want. Well, the strcmp function does, and its name, in fact, means string compare. Fourth, it's often necessary to change between upper and lowercase letters. For that, we can use the function named lower to convert a string to all lowercase, and upper to do the opposite. Fifth and finally, sometimes we need to print with fancy formatting into a string instead of into the command window or into a file. For that, we have the sprintf function, which means string print formatted, and it's often pronounced sprintf. It's a snap to learn because the only difference from fprintf is that sprintf puts its result into its output argument. Okay, let's try these functions out. Let's try searching first. So what does the for mean? It's the index of the first letter of the first occurrence of the substring in the string. Okay, now let me try that in English. We're looking for LAB, and we found it. The first time we found it, in this case the only time we encountered it, is at position 4 in the string. 1, 2, 3, 4. Character 4. That's where the first character of the string LAB occurs in the string MATLAB for Smarties. It's the first place the second argument occurred in the first argument. But remember, these strings are case sensitive. Let's try this. This time we get the empty matrix. MATLAB in the title up here is in all caps, so there is no lowercase LAB in this string. So there's no index to return this time. That's why we get the empty array. And I'm sure you've heard it said that there's no I in team. Well, let's check. Well, that proves it. I is definitely not in there. Sorry. No, I am. No. Anyway, so far we've either not found the substring we were looking for, or we've found it once. Let's do one more example in which we see what it looks like when we find something more than once. The substring R, right here, shows up in two places in MOOC title. Let's see, MOOC title was MATLAB for Smarties. And there's an R right here at the end of the word for. That's character 10. And there's an R in Smarties, which is the 15th character. So find string returns the vector 10, 15. Okay, that's it for searching strings. Now it's time to compare strings again. Remember the trouble we had before when we tried to do that with a double equals operator? Well, now we're better equipped to tackle this problem because we know about the string compare function, strcmp. Okay, let's review what happened here. First of all, we reminded ourselves what was in MOOC title, MATLAB for Smarties. Then we defined this variable lang by setting it equal to the string MATLAB. Then we compared MATLAB for Smarties with MATLAB. Well, MATLAB for Smarties is not the same as MATLAB. MATLAB's a substring of it, but they're not the same, so we get a 0, or false, meaning they're not the same. Next thing we did was just take the first 6 characters in MATLAB for Smarties right here, compared that with lang. Now they're the same, so we get true, or a 1. Couldn't be any easier. It returns true or false depending on whether the strings and the two arguments are the same or not. Case sensitivity applies here too, but if we don't care about that, we can use strcmpi, which stands for string compare ignoring case. Let's try that. Well, we get true. Clearly, MATLAB is not the same string as the first 6 characters of MATLAB for Smarties because this isn't all caps. But this little I here in strcmpi means ignoring case. Ignoring case, they are the same. So we get a 1. This ignoring case has nothing to do with anything other than characters that are letters. Doesn't affect punctuation, doesn't affect digits. By the way, if you ever need to convert a string to lowercase or to uppercase, check out the built-in functions lower and upper. Let me emphasize again how different strings containing digits are from numbers. The only difference here is I put quotes around the 3.1416 down here, but that makes this a string. These two variables have values that are completely different. This is a number, this is a string. We know that because we just typed them in. But MATLAB doesn't put quotes around the string here, so it is easy to confuse these two sometimes. There is one subtle hint. Numbers are indented, strings are not. Let's see how different they are. First, they have different dimensions. 1 by 1, it's a scalar. 1 by 6, it's a row vector of 6 characters. And speaking of characters, they have different types. And look what happens if you try to use them in arithmetic. No surprise there. 4.1416 is 3.1416 plus 1. But look at this. What is this? Well, what's happened here is that we've done mixed mode arithmetic. We've added one value, that's a char, to another value, here the 1, that's a double. A bit earlier in this lesson, we mentioned that the rules for mixed mode arithmetic, mixed mode meaning mixed types of operands, are complicated enough that we're leaving it to you to look them up in the textbook. But I'll explain what happened here. The rule for mixing chars and doubles is that before the addition, the char is converted to a double. So it's as if we did this. We get the same result. If we look at the term on the left converted to a double, it all makes sense. The 51 became a 52 and we added 1 to it, the 46 to a 47, and so on. It's just array addition with a vector and a scalar. It makes sense, but it's not something we'd want to do, unless we're encoding secret messages again. What we might want to do is convert the string 3.1416, way up here, to the number 3.1416, and then add 1. You'll sometimes find, for example, that your program must read a string of digits that a user typed in or that's in a file, and then it has to convert it to a number and do arithmetic on it. Well, by now you're probably tired of me. Well, I could probably just stop right there. You are probably tired of me. I'm tired of me, for goodness sakes. What I was going to say was, tired of me posing a problem just so I can have an excuse to introduce just the perfect built-in function to solve it. Okay, but be that as it may, there is just a perfect built-in function that'll solve this problem. It's called str, the digit 2, num, which means string to number. Let me write it out here. And I'll give it pi digits and convert it. Notice that it's indented over here. That's a little hint that this is actually not a string, but a number. And let's prove it's a number by adding 1 to it. There, 4.1416. And you probably won't be surprised to learn that you can go in the other direction, number to string. And notice that this isn't indented. Let's try to add 1 to it. And there we go. It's deja vu all over again. Okay, there's just one more string function that I want to show you. Remember earlier when we were saying that there was this function sprintf, and it's a snap to learn because of how similar it is to fprintf and so on? No? Well, that's okay. All you need is one example and you've got it. It's easy, don't worry. Let's see. Okay, we've got a variable r12, and we want to use fprintf first to print something to the command window involving r. Here goes. Okay, that's straightforward. We've got this format string here with the format specifiers, escape symbols, and so on. And the first argument r is printed point to f, 2 decimal places. Then pi r square printed the same way. And we put a little exclamation point there, and that's it. Now I'm going to repeat this command by using the up arrow key on my keyboard. But I'm going to come over here and change one character. I'm going to change this F to an S and see what happens. Okay, here we go. Nothing. This is sprintf. Everything is the same. Everything you've learned about fprintf is the same. But where'd the output go? Well, instead of printing to the screen, sprintf puts the text into an output argument. We didn't see anything because we put this semicolon here. Let's give it an output argument that it can stick things into. I'm going to hit the up arrow key again and come over here, and I'm going to give it an output argument str for string. There. Still don't see anything because we still have the semicolon, but now we know that there's something in str, or at least we hope so. Let's have a look at it. There we go. The area of a circle with radius 12 is 452.39. Same exclamation point, everything's the same. Even that line feed showed up here. That's why there's a space. So you can see that sprintf constructs a string using a format string, using arguments after the format string, just in exactly the same way that fprintf does. Except it puts the result into an output argument. And what's the type of the output argument? It's a string. It's elements of type char. Well, that's it for sprintf, and that is all I have to say about strings.